Okay, I think we can start. So good afternoon, everyone. My name is Nick. I'm the head of BD at xyzt.ai, and I will be the moderator today. First of all, I want to thank you all for taking the time to join our first webinar of the year entitled Tear Down Your Big Data Analytics Now. So before going over the agenda and tell you what it will be all about today, I want to first of all also introduce to you Bart Adams. So Bart is one of the two founders of xyzt, and he's also the CTO. Before going through the agenda, I also want to mention a few points. So for some interactivity, we will ask you some questions, some poll questions during the webinar. So it would be great if everybody can just click a reply. If you have any questions, you can obviously all ask them through the Q&A section at the bottom of your screen. We will try to answer as much as possible at the end of the webinar. If not, we will definitely come back to your question via email. The webinar will also be recorded, and we will share the recording with you as soon as possible after the event. And then I would like to also ask you, for those who haven't done it yet, to just mute yourself during the webinar. So the agenda for today. First of all, we will start with some concrete examples, things that we learned from our customers. So I will give two examples, one maritime example and one mobility example, and then we will build the new features and the story around the new features upon those examples. After that, Bart will explain to us the first of the two new features, which is the concept of data stores. Very exciting feature which will enable you to upload and visualize even more data than you could before. Third one is about the query language. So it's a whole new SQL type of language which Bart and his team developed, and which will enable you to run even more advanced queries. And then we will end the webinar with some of the key takeaways from today. So first things first, the example, drawing in your data dumps. We worked out two examples. So one is mobility one, and the other one is a maritime one. So I will just take you through a little story. Imagine that you are an analyst and you are tasked, for example, to analyze all the cargo traffic coming through the Los Angeles area. You need to figure out trends, dwell times, origin destination matrices. You know that your port authority has the historical AIS data available. AIS data is GPS data from vessels with additional properties, such as whether a ship is a cargo vessel or not. Or in the case of mobility, you're a traffic analyst working with for the road authority, and you need to make a report on traffic diversion due to the closure of a major highway, for example. You know, you also have all the floating vehicle data. Floating vehicle data, for who is not familiar with it, is GPS data of connected vehicles. And then, as the icing on the cake, your supervisor also expects you to deliver the report by the end of this week. For some, it will sound like a terrible job, but with xyzt, it will be like a doable job. Bart?
Thank you, Nick. And thank you all for joining the webinar in so large numbers today. So yes, today we're going to talk you through how to do this job in a week. But first, I want to take a step back and uncover the pains that typical big data analysts encounter. And it really starts at the beginning. They drown in data dumps. If you think about historic data like AIS data and floating vehicle data, it is a huge data set. And typically when you buy data, data vendors dump their data on you, and literally dump by providing you, for example, an S3 bucket with terabytes and terabytes of data, which is typically just flat files, unstructured files, CSV files, for example, Parquet files, for example. They cover large periods, they cover large areas. There's no structure really in this data. And it's a lot of data. So how do you get started with getting the data that you need to do your analysis? How to really drill down in your data? And really, if you look at this problem, the pains add up. And the result is that what we see is that big data investments often go to waste because the data is acquired, it's purchased, it's not cheap, but people cannot use the data to the full extent. First of all, as an analyst, typically what we see is that analysts, they are not knowledgeable on the platforms that are there. They're not knowledgeable on the cloud platforms they can choose to handle the data. Second, if you start working with the data, just copying the data around and starting to parse the data, running through the data is slow, and it can be a real cost in the cloud to do so. And thirdly, in many organizations, we see that analysts have to depend on their technical colleagues, which are often in a different department. They have their priorities. They are oversubscribed by different business units. And the result is an infinite backlog of data and analysis requests. So a backlog means that there's so many questions that they cannot be answered and handled by the team. And we identify this in many organizations. It's not just in maritime and mobility, but it's also happening in IoT. And we call it the data scientist bottleneck. So typically an organization has many business units with many analysts, but only a few, if they're lucky, data scientists who can handle data. So they become the bottleneck. And that's what you see here. So that's why we are in the business. We are xyzt.ai. We are a visual analytics platform that is extremely interactive and that can handle this big data without coding. And it means that analysts can extract insights from spatial-temporal data easily and efficiently. We're being used by enterprises throughout the world, but also by government agencies in maritime mobility and smart city. So just to give you an example for the people that are new to the platform, this is one of the screens of the analytical pages on the platform. It allows you to look at vast numbers of data. And what you see here is actually a data set from Spire. It's about a month of maritime GPS data, AIS data throughout the world. And as you can see, I can navigate through the data by zooming in and out, by changing time filters, by applying attribute filters. Like, for example, only highlighting here the fishing vessels. I can change the styling, the coloring, and I can run all types of analytics on the data. And as you can see, it is a lot of data, and it is very interactive. And the analysts can really see what they do, and they can let them be guided by the visualizations of the charts, the trends, and so on. It's not just about analyzing data. They can also build beautiful dashboards, reports, so to speak, that they can share with their colleagues, stakeholders, customers, the press, the politics, anyone they want to share the reports with. So very high level overview of the platform. And that brings me to the first poll question, Nick.
Thank you very much, Bart. So first question for today. What is your organization's largest big data pain? Is it A, data is not used or not used to its full potential? B, only few people can work with data? C, our monthly cloud bill is too high? Or D, other? We will give you a few seconds to reply. Okay. And this is the answers. So I think that most of you know that data is not used or not used to its full potential. So it's definitely something we can work with for our first topic of today, or our first big topic of today, which is the data stores. And that is just it's a topic which is around the size of the data and how more people within the organization will be able to use the data that is available. So Bart, over to you again.
Yes, thank you, Nick. Yeah, and I'm really excited about announcing these 2 new features to the platform, and I'm going to try to do my best to speak to the new people and to the existing customers of xyzt.ai. So what are data stores? Well, data stores basically are a concept that we introduced that allows you to upload any size data. So imagine that you have terabytes and terabytes of CSV files, for example, with all the GPS locations of the ships or the GPS locations of the floating vehicle data. You can just upload the data. You can do it with drag and drop, or you can do it with an API into a data store. And from that point on, that data becomes available for analysts to use. And I'll show you how to do that. But what is most importantly is that the analyst doesn't have to care about SQL queries or doesn't have to care about coding. It's really a no-code, click-only concept. So it's unlimited. You can store all your data. You can do very efficient extractions. So imagine you have 3 years of AIS data and you need to extract only a couple months. You can do that very efficiently. So it's indexed spatially, temporally, and on the data attributes. It's fully managed. There's almost no configuration needed to set up a data store. Of course, you have to configure it to adapt to your data, to the attributes of your data, but that's the only thing to do. It's super familiar. You will see it's very similar to other concepts in the platform, and it's really self-serve. So you don't need to go to your technical colleagues. You can just do your query yourself. There's a full API as well. We have customers that integrate the platform into their solution, so they can wire everything together with APIs. So what does it look like to start working with a subset of data in your data store? So imagine you have years and years of AIS data and you want to extract exactly the data that you need for your report, for your analysis. Well, this screen is what we call the quick extract screen. And first of all, it allows you to see where do I have data. And the red area is where there's no data. And inside the box, you see, okay, that's the region of interest. There we have data. So the first thing the analyst can do is zoom in on this. For example, navigate to a specific area to select, okay, I need data in this area. Second thing to do is to select the time period. You can do that relative to the data, or you can do that in absolute numbers, absolute date, sorry. And the third thing is to apply filters. Like, for example, I only want to see cargo traffic, or I only want to see heavy trucks in the resulting data set. And then finally, you can choose to create a new data set, but you can also add the extracted data to an existing data set. So you can combine different extractions into one data set. Now, for the existing customers, what's the difference between a data set and a data store? Well, they're very similar, but there are a few subtle differences. A data set is basically something that where you upload data in very much the same way as you can do with a data store, but you can immediately start using it for analysis. So there's no wait time. You have immediate access to the data, and you can visualize and analyze the data as I show in the movie before. The only difference with the data store is that there's a restriction in number of records. And this is for our cloud users. We restricted it to 1 billion records in one data set, which is already a lot more than the other solutions can handle. So what is a data store? It leaves this limitation. You have unlimited upload possibilities to a single data store. The drawback is that you have to extract a data set from a data store by doing this query that I showed. So Nick, that's a data store. Brings me back maybe to one of the questions that you had.
Yes, indeed. Sounds very interesting. But now, actually, I think what everybody wants to know is how would those data stores now help our maritime analysts to extract all the data that goes through the Port of Los Angeles?
Okay, so let me give a demo. I'm not going to do a full analysis and I'm not going to build a full report, but what I'm going to do is I'm going to show you how to work with a data store and start having access to the data that you want. And I'm not going to use a quick extract in this case. I'm going to use a more advanced extract. So you see the data store here, and at the bottom, you see the time period where there's data. If I zoom in on Los Angeles, because I need all the traffic, all the vessel traffic through Los Angeles, I'm going to create a circle here that I'm going to use as a filter on the data. I give it a name, and I apply immediately a true filter. I set a filter like this, and what you will see on the right side of the screen, above the extract data set, you will see that there's now a chip that says, okay, this filter is set. I'm going to set a very specific date because I'm asked to only analyze the first quarter of 22. So I set a date range between an absolute and begin and end time. And then the final thing I'm going to do is I'm going to zoom out my view because I want to see the data not just in the Los Angeles area, but I also want to see where the traffic comes from. And as a final thing, I'm going to add an attribute filter. In this case, I'm just going to restrict it to AIS vessel type 70, which is a subset of the cargo traffic, but I could add more filters there. And then I hit the extract button. And the only thing I still have to do is fill in a name and maybe a description so that my fellow colleagues can see what this data set is about. You also get some statistics on the amount of data that you selected so that you have an idea how big the resulting data set will be. I will also attach it, and then I hit the extract button. And what you will see is that when I go to my data sets on the left, and I do that by here on the left, click on the navigation bar, you see that I now have a data set that is queued. And this means that this extraction process is waiting for a cloud service to be able to process this data. It's now running. And if I would now go to my project card, and this is the project that I have, simple project, you see the data set is also there in the project. So I have my data store in my project and I have my data set in my project. If I click on Visual Analytics, you will see the data is there. And I now see the data that I extracted from the data store. So you can imagine someone else, another analyst, has access to the same data store, but can extract a different data set and do their analysis. It's all just by clicking. And then they can do their job. They can define their anchorage zones or upload their anchorage zones, do the analysis on the different anchorage zones. Like you can see here, there's like a trend analysis comparing traffic in those different anchorage zones. So you see, Nick, it's all clicking with the mouse, a little bit of typing here and there, but there's really no interaction with the technical colleague needed once the data stores are there and available to the analysts. So that's my demo now. And I think it brings me to the second poll question.
Yes. So now seeing this demo, very interesting. And now we have another poll question related to the storage solutions that you are using right now. So are those one of the cloud providers? We think about the typical ones. B, only local storage. C, a traditional SQL database. D, a NoSQL database. Or E, other. We will again give you a couple of seconds to answer the question. Okay. Yes. Results. Two answers coming out. So most of you either have a cloud provider or a traditional SQL database. That also brings me to the second or the third topic of today. Now we will talk about something completely different. We will talk about the easy access to your data. So how to get your insights using the powerful query language. Here again, we have some feedback from our customers. So our users, they have been working with our platform on the most diverse and challenging analytic tasks over the past years. And one thing we learned is that they all have so many different questions to answer. So like, for example, a traffic analyst might want to see a heat map of all trucks leaving Frankfurt and driving through Munich. Another analyst might want to see a speed profile of traffic on a specific highway lane during a specific time period. Or a smart city analyst wants to analyze heavy traffic near primary schools. So Bart, I think the question we all have here, how do we cope with this unlimited amount of different questions?
Yes, thank you, Nick. Yeah, so as a product manager also for the platform, it's really daunting how many different analytics people do. And we even see that one person, once they start looking at the data and doing their analytics, they have so many more questions that they want to ask. And we analyzed all those questions and we identified key building blocks that are always present or most of the time present in the questions that people have. The first one is, of course, spatial filters or spatial queries. People want to see where the flow of traffic comes from, where it goes to, where it doesn't go to, where it goes through. And this applies to mobility, to maritime, to people flow. We see it in all the different verticals where there's movement data. Second, of course, is a temporal aspect. If you look at traffic, for example, on the highway, a morning commute is very different from an evening commute. So temporal filters are also what we see coming back again and again. And temporal filters can also be duration filters. Like, for example, I want to see traffic that's been on the road for more than 3 hours, for example. Then the third key component is attribute filters. Like in the data store, I had to filter out only the cargo traffic. Here also on the road, people want to see what's the effect of traffic diversion on the heavy traffic, for example. And then people like to combine all those different things. I want to see this and this, or I want to see this or this, or I don't want to see the traffic that goes through that area. So, and this is what we call Boolean operations. And I think, Nick, you remember this from high school. This is how you combine basically different queries, different concepts. And then finally, temporal sequences. And this is something that is extremely difficult in traditional approaches. Typically, what we see in analysis is that people want to see a flow of things happening. Like, I want to see all the vessel traffic first leaving Los Angeles, then going to Houston, and then maybe going to the port of Antwerp. It's the same in the road traffic analysis. People want to see traffic flows, specific flows. And the demo I'm going to give is an extreme example of that. So we identified those building blocks and we came up with a new language. And we call it ASTQL, the Advanced Space-Time Query Language. And you see space and time is in there because it's so important in all the different queries that we saw. Before we had this language, we already had some filtering and we changed the name of that filtering to basic filtering. And it allows you to do combinations of spatial filters, temporal filters, attribute filters, but it's a UI only concept. So you have to click and put your filters in place. The new query language extends on this, and it also adds those more advanced filters and combinations with Booleans and temporal sequences. But it's also a textual representation, which proved to be extremely powerful and extremely intuitive to basically see what is going on, to better understand what a filter is about. And the nice thing is those textual filters can also be used through the API. So that's what I want to show later in the demo, Nick, but I think you're going to give a little bit of context to the demo.
Yes, sounds very cool. Advanced space-time query language. Sounds like really a powerful feature for analytics, and I'm convinced it is. So I really thought about, do we have an example of a real customer who could use this language? And I think this one here is a very good example of this. So actually, to give a bit of context on what you see, it's a bridge on the highway A45 near Ludenscheid in the North Rhine-Westphalia in central Germany, or at least it was a bridge. So a couple of years back, this bridge got demolished and it was not fit anymore to carry traffic. And if you look at the map, you can see how the A45 is now cut and actually traffic cannot flow over the highway anymore. So being such a central corridor in a highly populated area, you can imagine the traffic challenges this brings. So Bart, I hope your traffic analyst can help the road authorities with this case.
Yes, for sure. I'll try to convince you that it's possible to analyze the situation. So really what is happening, traffic flows differently, and there's a lot of problems now with traffic going off the highway into the villages, into the cities nearby that shouldn't be there. And the example I'm going to show with the query language, it's a mobility traffic example, but you can use the exact same concepts and the exact same analogies in a maritime context or a people flow context, or we even have people using it with forklifts that are tracked in warehouses. So this is a situation. The screen that you see here is with data from Inrix. Inrix is one of our partners where we do quite a bit of projects in Germany now, and they provide floating vehicle data. And you see here a heat map of the traffic through that area. So you see where it comes from, where it goes to, and you see where the densities are. And you see there's a lot of traffic. Just to set the scene, and because I know some of you are not familiar with floating vehicle data, I'm going to introduce a couple of concepts. The first thing is a trip. A trip is basically a sequence of GPS points of a vehicle driving. So a vehicle is leaving somewhere and it's going to somewhere, and in between it's at different locations. In the platform, we call a trip an asset. Typically, a trip can be also a car, a vehicle, a vessel, a forklift, and that is what we call an asset. The GPS points is themselves, which can be just a GPS point, but there's always also a timestamp. There can be velocity attached. There can be vehicle type attached. We call it in the platform a record. And that's typically also what you would call when you put something in a database, it's going to be a record. So having these concepts in place, the question that we're asking, and this is just an example question. So use your imagination, anything will be possible. So show me all light traffic leaving the A1, which is a major highway here. So leaving the A1, driving towards Ludenscheid on the A45. So this is the A45, this highway. And this is Ludenscheid, this area. It's very close to the closure of the highway 45. And then additionally, the question is, of course, to analyze it during the commute hours, for example, the morning commute. So you see, it's a simple question, but in fact, it's not easy to do with existing tools. It's just an example question, so you can always use different questions. So why is this question important to traffic analysts? Well, this crossing here that you see in the north is one of the last decision points that people can make to keep following the A45 or to basically take a different route south. So that's basically an important decision point. So what we did is we analyzed all those questions and we broke them down, and we saw there's always three different parts. The first part is basically selecting the subset of assets, the subset of types of vehicles or types of trips, types of vessels in a maritime context, and that we call an asset filter. So basically you do sort of a query on the whole trips, and you leave out all the trips that do not fulfill the query. Second part is the asset route filter. And that's really where the difficulties lie. That's where you want to analyze the flow of things. Okay, it has to be on the A1 first, then it has to go to the A45, and then it has to go to Ludenscheid. So that we call the asset route filter. So route is important here. It consists of different legs. And then finally, what we identified is that people then, once they've established this query, they want to restrict it even further to the individual records, to the individual GPS waypoints. Like, for example, only the records between 6 in the morning and 10 in the morning to have the morning commute, or between the first day of the week, which in the platform is going to be a Monday, until the last working day of the week, which is a Friday, number 5. And that we call a record filter. So today, I'm mostly going to focus on this middle part because that's where really the magic happens. And I'm super excited about this, that the engineers could get this done. And before showing the demo in the platform, I'm going to walk you through building a query. And it takes some steps to understand. And the first time, there's sort of a learning curve to it. But once you see how it works and how powerful it is, it can really unlock your imagination and remove any limits in your analysis. The first thing an analyst has to do is when they analyze traffic through certain regions, whether it's a highway section or whether it's an anchorage zone in maritime, is define the area. You can upload files like shape files, GeoJSON files, or you can just draw those areas. And in this analysis, this is like the area that we're interested in, and this is an area that we're interested in. And you will see that I've drawn three areas here just to be able to filter out a certain flow of the traffic. And that's what I'm going to show now. Second step is to really describe the route that a trip has to follow to be able to filter out only the trips that fulfill my query. And I'm going to start with the first part, and I'm going to build it up gradually. And this is what such a filter looks like. It's an asset route filter. And basically what it says, I only want to see the trips that have a sequence of waypoints that is inside the area that I defined. So basically you're saying only the waypoints inside the area. Then I'm saying the trip can do anything. It can leave the area, it can be anywhere. And then finally, I say it has to be inside the A45S area. So those names that you see, those strings, they come from the names on the map. Here in the middle, you see sort of a temporal representation of my query. So imagine you have a trip or a route. There's a part of the trip that is not selected. Then it has to be inside. Then it can follow any path, and then it has to be inside this area. So this is the first step in my query because this gives me the traffic flowing like this. At least I think, but it's not exactly like that. There's a small problem with this query, and it's highlighted here on the map. Basically, this trip, for example, a car or a truck driving from the south to the north, it enters the A1N area. Then it can be anywhere, so it drives back to Dortmund here, it gets back on the highway here, and then it goes to A45S. So you see this red section of a trip also fulfills the query, or it also gives a true result because matching this against this trip is also true. It's also correct. And this is not what we want. We really want to see the traffic coming from the north side driving to the south side because that's what the analyst is analyzing. So basically to solve this, I can restrict my query and change the any to the inside this circle. And Kreuz means crossing in German because this is a German use case. And this restricts my trips further. So it only applies now to trips like this. And you would imagine that the previous thing is not happening, but it happens a lot. People drive around, think about package deliveries, drive around in all types of circular patterns through traffic. So is this my final query? No, because what are we looking at? We're only looking at the part of the trip inside those three areas, because that's what we defined here. So what I can do is I can add another section to my route saying, for example, any. And I think some of you might already see this is not gonna cut it because any means literally any, so any part of the trip. And this filter will also select trips that drive like this, but then they don't go to Ludenscheid. They drive away east or they drive away west, for example. So we have to extend our query. And the easy thing to do is just create an area on the map and use it here into the asset routes section. And this gives you all the traffic that at some point enters Ludenscheid. Now, what I want to know is I only want to see the traffic that ends in Ludenscheid. Because maybe as an analyst, I want to identify what's the proportion between traffic driving through and traffic that has to be inside Ludenscheid. For example, someone living in that city has to be there, so they are validly going through the city. And here it is where Boolean combinations enter. So instead of just saying it has to be inside Ludenscheid, in the query language, you can say that the endpoint of the trip has to be inside Ludenscheid. So here we're adding two conditions together, and we're saying, okay, only the trips that end in Ludenscheid. I know it's a lot to digest. So what I'm going to do is I'm going to give it live now in the platform. And I'm going to do a similar query to show you how it works. So what I'm doing here is I'm creating a project from scratch. Call it Advanced Space-Time Query Language. And I'm going to attach a number of resources to the project. So the first thing, very quickly here, I'm going to add some background data. And I'm going to use one of the sample data sets. If you would register to the free trial, for example, you would get that. And this is what you get. So you're looking at INRIX floating vehicle data. And the heat map that you see is actually hundreds and hundreds of millions of GPS points. So you see 4 weeks of traffic through this area. In the example, the first 2 weeks are before the closure of the highway, and the last 2 weeks are during the closure. And that's what I'm showing you now. So let me disable the data set for a while. So this is the first crossing, but this is not the decision point. This is the decision point where people get off the A1 onto the A45. So what I'm going to do now is I'm going to use the toolbar at the top, and I'm going to draw a couple polygons. So let me first create this one here. And I'm going to give it the same name as before. This is the A1N. So it's a section on the A1 north of the crossing. I'm also going to use this section. I'm going to show you how to also capture the traffic coming from this area. So that's the A45 northern section. And then I'm going to select also this. And you see I'm using polygons and areas, even in a traffic flow analysis, which also means that you could try and identify, for example, traffic at a specific traffic lane. But it also means that you can do the exact same analysis in a maritime context where there's no road network, or in a people flow or bicycle flow context, also where there's no real good network available to do your analysis on. So I enabled the filter again, the data again, sorry for that. What I can do is I can just click and apply filters like what was possible before. So I right click on the shape, apply an inside filter or a true filter. But I want to show now how to use this new powerful query language like I did before. So I'm going to focus on the asset route again, because that's really the most difficult part. And I'm going to start typing here. You see I'm typing inside area. The name is A1N. So that's the first shape that I created. And you see the filter is applied. It's shown on the map. It's also shown on the timeline. You see how many trips are there over the time period. And it's also shown on the right on the statistics. I can see now I have like 16,809 trips. So I'm going to do some copy pasting because I have to implement this flow query. And so I'm going to add 3 inside filters. So I want to have the traffic first in A1N, then in the Kreuz, and then in the A45S. And you will see that the platform updates almost immediately, typically within a second, sometimes a few seconds, depending on the number of records that it's going through. And in this case, it's really literally going through hundreds and hundreds of millions of GPS points. What I'm going to do here is a little bit different from the example before, because I have a little bit time left. I'm going to also include the A45N traffic. So the traffic that comes from the northern side of the A45 compared to the crossing, and that stays on the highway and that drives south. So this gives me an idea of all the traffic that drives towards the problematic area. And you see the platform updated, you see the two traffic flows, you get immediate visual feedback on what you're doing. So you really see what you're doing while typing those queries. I'm making the background a little bit darker to make the foreground data a little bit more visible. So as I showed before, typing the any filter, it will update the platform and it will show for the trips that were selected by the first part, also where they go after leaving that area. So you see, there's a lot of traffic and you see it's really flooded over the area. It's not just one single diversion route they take multiple routes. So like in the demo, and I apologize if I sometimes go a little bit quick, but I want to stay a little bit within the time of the webinar. So here I'm gonna draw a final polygon. It's actually the polygon that I'm drawing now very quickly over the inhabited area near the A45. Call it Ludenscheid because that's the name of the city there. And then the only thing that is left is to start using that area into my filter. So let me open the advanced filter editor again. You see it ended with just selecting the remaining part of the trips with the any filter. I'm going to change that now to really select only the trips that go through this Ludenscheid area. So the first thing I do is, okay, in between the A45S area, it can be anywhere, but at some point after that, it has to be in the Ludenscheid area. And that's what you see here. So that's that query. So now the platform will update. Yes, and here we are, 9,000 trips. And these are all the trips that come from the north and stay on the A45 and drive through Ludenscheid. The final step I have to do is, okay, do I want to see only the trips that end, or do I want to see the trips that drive through? And the first thing I'm going to do is show you how to do the trips that end. So basically, remember, I have to do the Boolean combination. I have to say that the endpoint is inside Ludenscheid. And that's what I'm doing here. You see, it's about a little under 2,000 trips. So this is how analysts can build up any query that they want. And it's really nice and logical to follow. What you see here is it's different legs. We call it legs. So it's you start from the beginning of the flow to the end of the flow. You get immediate feedback on the map, even for billions of data points. And Nick, you mentioned it's not related to the data stores, but in fact, you can even use this filter to extract data from a data store. So if you have a data store of even more data, you can use this filter for a data store. So what I'm going to do also finally is show you, okay, how do I select the true traffic? And this is just negating this last condition. So now I'm seeing all the traffic that stays on the A45 or gets on the A45 and drives through the city area of Ludenscheid. And you see it's more than 7,000 trips. So there's a lot more traffic going through Ludenscheid than inside Ludenscheid. And this is problematic. This is what a traffic analyst wants to analyze and monitor. So people are clearly not following the traffic diversions that are in place. They don't stay on the highway. They really drive through the small roads through the villages. And what we see our users doing is, what I do here is I create a second map. And on the left map, I will keep showing the true traffic. And on the right map, I'm going to change my filter again back to the traffic that ends in Ludenscheid. And this way you can compare. You can compare one situation with the other. And you see, let me disable some layers here and some data. Well, you see it here. So you see like 7,000 trips through, 2,000 trips end. And this is the type of insight that people get out of the data from the platform. And of course, Nick, and I'm not going to do that today because we're running short on time, you can build a report of this. You can make dashboards with the widgets that you see and share those with other users. So I really focused on this middle part, the asset route, and I didn't focus on those two other parts. I'll just give you a view on what it looks like, but it's very simple and it's very similar. For example, the last part, selecting the records, is just like this. So I need an and I need the hour to be between and the weekday to be between. So it reads very, very logical. So what are the benefits? No more limits, because that's the theme of the webinar. You can virtually describe any traffic flow filter and get insights immediately. It's very clear and logical. People can really read from top to bottom and understand the query just from reading the query. It's easy to copy paste around. You can also use it through the API. And it also enables you to maintain a cookbook. What we've seen people doing is they create different queries. They keep the text somewhere on a documentation platform that they have, adds maybe some explanation with the query, and then they can start reusing the same query for different tasks. And we've really seen that using this powerful query, analysts can get insights much, much quicker than data scientists who are building their own queries on the data, for example, with Python or with other scripting languages. So Nick, I know I was a bit over time, but I wanted to show it 2 times because the first time you see it, you have to digest it, and then the second time you see the power of it in the platform, and I hope I could convey that. So that leaves me with the demo.
Okay, thank you very much, Bart. I think for sure that the advanced query language is very powerful. So as last part of this webinar today, I want to take you to the takeaways, so the key takeaways of today. So the first one, I think we can all agree that working with big movements, data sets should not be a pain, given the data stores, of course. Second one is extracting insights requires a powerful query language, which we also showed you. Third one is self-serve with on-demand analysis flexibility is now possible. So you no longer depend on another colleague. And the fourth one is we can use it with any spatio-temporal data. So before ending this webinar with the Q&A, we still have one last question for you. Do you want to learn more? Everybody, of course, know that the right answer is A. Yes, please reach out to me. But there is also B, not for now, but keep me updated, or C, no thanks. So we will again give you some couple of seconds to answer the last question for today. And then we will go to the Q&A round. So everybody voted. Then to really end this webinar, we still have a small Q&A round. So we have received some questions. We'll try to fit in as much as possible, but I also see that we are running out of time. So one of the first questions that we received is, how easily can I share the results with my colleagues or managers? So Bart, I think maybe that's a question that you can reply to.
Yes. Yeah, I didn't show that part of the platform, but indeed you can share basically any page in the platform. But most importantly, the dashboard that people build, you can create a shared link. You can send it around to anyone. They can click on it and see basically the page that you prepared. Of course, we also have people that use the platform and they download, for example, the charts or the visuals and include it in their own reporting mechanism. So that's also possible. But yes, the platform is meant for collaboration, it's meant for sharing, and it's used like that by analysts to share their insights with stakeholders.
Okay, great. Thank you very much. Second question I will pick out is, do we also provide data? That is maybe one that I can answer myself. We don't provide the data. However, given our platform is meant to visualize and analyze location data, we do have the connections and we do know the right people at the different companies, whether it is data used in maritime industry, mobility, or IoT. So we can definitely point you in the right direction, but we don't sell it ourselves. Third question, and I will maybe end with that one, is, and that's also a very important one, which type of data do we accept in the platform? So Bart, that is maybe, again, a question that you can reply to.
Sure. So the platform is called xyzt.ai. The XYZ comes from location, T from time. So as soon as you have spatial temporal data, the platform really shines, and it's extremely powerful to get insights out of that data. This means that data typically has a spatial component, a location, a timestamp, and attributes. And what I've shown is movement data, basically where you have those assets or entities and GPS points. But we also accept, for example, time series data where the asset or the object or the sensor or the area doesn't move, but you have time varying multivariate data over those areas. So think of air quality sensors or traffic counters. And the platform is also optimized to handle that in big numbers. Typically, format-wise, what we see that most people upload is CSV files, GeoJSON files, shape files to the platform. That's the most common formats used.
Okay. Thank you very much, Bart. I received another question, but it's more an operational question. Will we record, have we recorded the webinar and will we share it? So the answer to that is yes. Tomorrow you will probably receive an email with the recording of the webinar. I think we replied to all the questions. So for now, I want to still say thank you again to everybody who joined us today. If you still think about questions or you think about something else, then don't hesitate to reach out to Bart or to myself. As mentioned, we will send out an email with all the recordings, information, demos, and so on and so forth. So for now, thanks to all of you to attend this webinar, and also a very big thank you to Bart for this very interesting webinar. And the only thing I can still add to that is enjoy the rest of your day.
Thank you.
Bye.
Bye.
Bye-bye.